Okay, so we basically got emptied the alumina column here that we used to dry and get rid of the peroxides from the THF into here, and that'll we just leave that under here and let it evaporate, because we're going to fill it up again with fresh material for our ether. Okay, it's diethyl ether that we'll be using to extract with. So again, we just set it up again. And we can just collect some ether right into here. Again, it doesn't have to be anhydrous, because we're going to be extracting with water. We're extracting an aqueous phase. But what we're doing is being sure there's no peroxides. Especially with the compounds that we happen to be working with now that have a lot of double bonds in them. You have to be exceedingly careful with peroxides. And again, ether, top, tight. Make sure that top is on tight. Oops, forgot. Why don't we let a little bit of it go through first? And it'll just splash here and evaporate, that's fine. Okay, good. It's always a good idea to let things go through a little first before you start collecting. Alright. And again, I prefer an Erlenmeyer here like this so that the ether you do collect won't evaporate the instant after you collect it. Okay, so that's collecting ether. Very good. What we need to do is make sure this pH here is, because of the pKa of carboxyls, which is about 4 to 4.5, in order to be sure we're 100% in the protonated form so that we can extract any unreacted fatty acid back into the ether, we have to make sure the pH is down to 2, about no higher than 2. Okay, so again, I'm just using a tiny tip here to just touch, because this is concentrated now, so I want the absolute bare minimum to test the pH. Again, I mean, just nothing. Whoa! Put it down like it was an Erlenmeyer. Okay, so again, I just want to be sure, see what the pH is now. Okay, actually, it's about 8, unfortunately. So we're going to have to add, I'm sorry, could you run around there? I have 1 molar HCl. Okay. Alright, so thank you. Alright, so again, anytime you're adding with stirring, alright, so I'll give it 2 or 3 drops of this. Just to be sure. Again, the point is to get it down to pH. Oh yeah, there we go. That's about pH 1 to 2. That's okay, 1 to 2, good. Alrighty, very good. And again, we have to be acidic. See the red? That's when, again, there's the color wheel right up here. If you need it, there's the color wheel. So we're definitely acidic. We're no problem. Okay. Again, even if it's like pH 1, that's fine for this short amount of time. Okay, so the question here is how do you, to clean this up? Getting that to clean up a bit. Okay, right where the reactive vials are stored is also these glass conical glass tubes. But they're graduated, and I like that because then I can know exactly what the volume is of my product right away without having to mess with it. And you have to use glass because we're using ether, and we don't want to ever use plastic with ether or anything like that for evaporating. Okay, so what's the first thing we can do? Well, the first thing we can do is just add almost an equal volume of ether and just let that stir around a little bit. Okay. Then we can worry about extracting later from here. Sometimes, again, sometimes solutions will clear up because, for example, sometimes things, two different compounds might precipitate, or one compound, when it precipitates, might cause the precipitation of another compound with it, or gets trapped with it. That's why I like to swirl around in here the ether and the water layers, and as you can see, things clean up a bit. There was some particles there before, and now if I look, there's still some particles, but the key thing here is that you want to get real good transfer out of here into here, for which you'll to do the extracting, as I'll show you. So again, I always add ether to here first. Okay, now what's the point? Now we can okay, so now basically it's just a matter of transferring everything that's here. Notice how it cleared up completely. Do you see that? Notice how it cleared up completely. What was originally all precipitated, see? Okay. Now, again, you don't really want the ether phase, because our CoA derivative is water soluble and is definitely not soluble in the ether phase. So, again, for maximum recovery, actually, if you look at here, this is almost exactly 2 mLs, which is what we predicted. It's almost exactly, it's a tad under 2 mLs. But for complete recovery, what I could do is actually just add a tad, quarter of an ml of water, and then spin it around again, and then suck up anything that's on the bottom. Again, the ether we don't want. There's nothing, absolutely nothing in the ether that we want. So I could just suck up a tiny little bit at the bottom. I mean, again, even if I do pull over some ether, it's no big deal because I'm going to get rid of it anyway. So there's our CoA derivative, and now we do what? Do another 1 or 2 extractions with it. Approximately equal volume. Again, keep this from evaporating. Again, there's a couple of ways to do that here. Without, the most important thing to prevent is emulsion. Because, and that's why I start off gentle. And you always hold near the top. Always hold at the top. Never hold like this and try to vortex. You'll never get anywhere. Hold at the very top. And you must see a vortex come down. But you don't want to over. Okay, that's it, once. And now I just test to see, and just look. I just test. I don't mean test. I mean I look to see if the phases separate evenly quickly. And yes, they are separated. What does that mean? That means I'm probably, there we go, I vortexed. Phases are separating. Fine, so that, again, here within 15 seconds they're completely separate. The worst thing in the world you want to have is an emulsion. Because then now you have to sit there and evaporate off all the ether using nitrogen, stream of nitrogen, and now you're back to where you started. So here the phases separate perfectly fine. Again, no problem. I can vortex it a few times here knowing that the phases are going to separate, no problem. Now sometimes you do run into an issue. Sometimes your acyl CoA acts like a detergent. If you have a long chain acyl CoA, especially you've got to watch out, because those act as detergents. I mean, they have such properties that the CoA part is soluble in water, but the alkyl chain isn't. And so you have a perfect setup for a detergent, which is now going to make nothing but emulsifying bubbles, emulsification, which is exactly what detergents do. Okay, so now what do I do? Now I can literally just spit off the ether that I don't want. You know, just suck it right up. You know, just get rid of it. Let it evaporate. And again, better safe than sorry. Better to leave a tad bit of your ether behind than to suck away your valuable CoA derivative. And so we extract again approximately equal amounts. And again, I already know. Again, just checking. Okay, emulsion. Pretty good. No problem. Okay, good. Now again, you do want the phases to intimately mix. I mean, otherwise you're not extracting anything. So you definitely do want them to intimately mix. But you also just, you know, again, be careful that you don't have a situation where you are in fact sitting with an emulsion. So sometimes you have to just vortex gently and just now let it settle again. Let the phases separate. But here in this particular case, we're okay. I could sit here and spin probably all day and they'll still separate okay. But yeah, definitely want intimate mixing. Very good. Okay. Good. Now I can just suck off the ether. Now we're going to leave a little bit of ether behind, so how do you get rid of that? Well, I'll use a nitrogen stream. Okay, so again, that's it. I'm not going to go any closer. So, how do you use a nitrogen stream? Well, basically, you can just sit this here and hopefully you can get this in without busting it. Again, lift it up a little bit and then put it down, tighten this up a little bit. And then you just got to make sure that this is attached. Alright. Now we don't need a you don't need a heavy stream. Just enough. Now, again, if this is too high, you'll never, just enough to disturb the surface. Oh. Sorry. Oh, tank is out. Tank is off, sorry. I'll tell you how to use the tank in a minute. Okay, now zoom in over here. Bring the whole thing over. And tip right down into it. See the surface? Zoom right into the surface.
Yeah.
You see the surface disturbing?
Yeah.
That's what you gotta see. If you don't see that, you're not doing anything. Alright, so as long as you see your surface disturbing like that, just leave it. And eventually the ether will all evaporate. Now it takes a good 15 minutes, 20 minutes. Okay. Okay, so we've been evaporating the ether. Again, you got to be sure that the surface of the ether is being disturbed vigorously, or else it won't disturb the very bottom of the solution here, and it'll take a real long time for the ether to come out. It actually takes longer than you expect, than you think, because again, it is a long, narrow tube. So, anyway, how do you know when the ether's all gone? You smell it, and you go, I don't smell any ether, and you know it's gone. Notice you have a fairly, clear solution. Now we just have to bring the pH up. The pH is best between 3 and 4. Much more acidic than 3 or 4, and then you stand chances of maybe being too acidic, and then you can mess up the CoA part of the molecule, even though the thioester is fine. Between pH 3 and 4, that's the perfect compromise. Your thioester is going to stay good, and your coenzyme A, the majority of your coenzyme A molecule will be fine. So, what do we have to do? What did I use this for? Oh, that's right. I asked for adding this. That's right. Now, it's a 1 to 200 dilution of this pre-prepared BHT solution. Sits up on the shelf here where the organic stuff is, right here on the shelf. And so 1 to 200 dilution will give 8 ppm of BHT, which is pretty good. To be honest, I'm going to give it an extra dosage. I'm going to give it 2. A 1 to 100, which means, so I'll give it 16 ppm. Again, like anything, you want to add with stirring. Okay, so again, a bit of stirring down the hatch. Good. There we go. Now, the BHT is only really necessary for CoA derivatives where you have conjugated double bonds in there. And the purpose is, again, it's a free radical scavenger, so it stops free radical chain reactions from propagating. It doesn't destroy free radicals. I mean, however many epoxides you have in there, it doesn't destroy peroxides. It just prevents them from, it traps them and helps them from, and prevents them from propagating chain reactions. Because the BHT itself is a free radical, but it's very stable, and as a result, it won't perpetuate the formation of other free radicals. Okay. So, there it is. And again, it should have a clear solution. This can be further purified by HPLC or solid phase extraction using a cartridge. Okay, so we're going to adjust the pH. The most important thing here is that you do not overshoot the pH. Why? Because if you happen to bring the pH up above, remember there's no buffer in here. So you have to be careful. Since there's no buffer in here, 1 or 2 extra drops of KOH, 1 molar KOH, might bring the pH way up. That's horrible, and the reason is because the thioester linkage that you just spent all this time making will start to hydrolyze. So if that in fact does happen, instantaneously put 1 or 2 drops of 1 molar HCl in to bring your pH right back down. Then you can creep it up again. Again, if you do it drop-wise, you'll have absolutely no problem. The other thing, again, when you're adding strong acids or strong bases, like this is KOH, again, notice how I'm pushing it out so there's no air bubbles. So I know I'm going to get a completely homogeneous drop when I do it. Stir, 1 drop down the pipe. Okay, let it go in. Good. Right? Now, for this, it's better to use just the Hamilton syringe. Because, and I mean it, you really just only need less than 1 microliter to do the pH. But you gotta go up, down, up, down, up, down, up, down, up, down. Again, you can stir it again maybe to just get to the right pH you want and then leave it. So again, taking up just 1 microliter. Putting it right on here, we want between 3 and 4. Alright, that's still way down. Okay, so another drop of KOH. Again, do it 1 drop at a time, and you'll never go wrong. You'll never. So again, make sure. I'm going to slow this down just a little here. Okay, 1 drop down the pipe. Take it up. Up, down, up, down, up, down, up, down, up, down, up, down to, you know, get the new pH. To rinse out the original portion of the syringe. Take up no less than, you know, you don't need more than 1 microliter. And you can see how tiny volumes here are needed. I mean, these are just, you know, microliters. Okay. The fact that that's still red here, 1 more drop. Just 1 more drop and we're probably real close. Again, up, down, up, down, up, down, up, down to rinse out the inside of the Hamilton syringe, and boom. See the orange? Orange and clear yellow. That's exactly what you want. Orange and clear yellow, that's like 3-ish. Bingo. We're there. Perfect. We're done. Thanks for watching.